Hello again. We're going to do a form of dividing polynomials, and it's called synthetic division. And it's really quite cool when you got a problem in this form. If you don't, that's a problem. You can't just sit there and say, oh, I want to use synthetic division. Well, you know, synthetic division works for maybe 1% of the problems that you're ever actually going to divide in a math book. If you want to think about how many problems you could divide with synthetic division in comparison to all the problems, it's considerably less than 1%. But it's cool because your teacher will probably test you on it at some point in an algebra class. And you could use it. And it helps you find things, but so does factoring. And we'll get to that one, but we're going to have to figure out how to divide properly. So here's how you do synthetic division. You've got 2x squared plus 3x plus 1 divided by x plus 1. You can only use synthetic division when it's a variable plus or minus a number. Not a number in front of the variable plus or minus a number. It has to be a variable plus or subtracted a number. It's so limited that your second number, I want to say it's a dividend, but I can't even remember that off the top of my head actually. Well, whatever you're dividing by has to be a variable plus or minus a number. That's it. That's it. Not variable squared, not variable by itself, just a variable plus or subtracted a number. That's why it's so limited. I can't preface that enough. It's synthetic division, it's cool, but you know, not really useful in everything. So here's what you do. You take the opposite of this sign. So if this is a positive 1, you make it a negative 1. And then you kind of surround it in a box. Now what you do is you take all the coefficients from the first polynomial. So if it's x squared plus 1, then you'd have to put a term for the x. But this one's nice and easy. It's got x squared, x, and constant, so it just flows right through. So the first coefficient is 2, the next coefficient is 3, and the next coefficient is 1. And at this stage in the game, students are so annoyed with dividing that when they see me do this problem, they're like, oh, I love this. I'm like, yeah, but it only works for so much. And they say, can we use this all the time? I'm like, no, because I won't structure my test that way. Okay, set them all equal. Here's what you do. The first coefficient, you drop down. It's a 2. Negative 1 times 2 is negative 2. Take 3, subtract 2, it's 1. Take negative 1 times 1, it's negative 1, that's a 0. You figured out your answer. What do you mean? I'll show you. The first term was an x squared, so go 1 degree less. So if it was an x squared, if it's an x cubed, make it an x squared. If it's an x squared, make it an x plus 1. That's your answer. 2x squared plus 3x plus 1 divided by x plus 1 is 2x plus 1. That's the answer. There's no remainder. Some of you might not believe me there. I'm going to do a factoring problem really quickly, although we haven't done factoring in a while. I'll prove it right now. X squared plus 3x plus 1 divided by x plus 1. I know that the signs are positive, positive. This is what I'm talking about. When I expect you to factor, you've got to be able to factor. Or any teacher does it. Just my lesson there. So this splits into two binomials, positive, positive, 2x and x. 1 times 1 is 1, bam. That's 1x plus 2x, 3x. I checked it. Check my factoring if you want to do that, or ask your teacher, look up factoring if you don't like the way I do it. Over x plus 1, 2x plus 1. Yep, that's synthetic division. It's a subset of dividing polynomials, but it's a cool little trick. Yeah. We're going to do some more interesting things that I think are more relevant to actually dividing polynomials. But for right now, have a good day. Goodbye.